Consider f, which is defined for all real numbers. At what arguments x is f of x not differentiable? So to think about that, I'm actually going to try to visualize what f prime of x must look like. So I'm going to do f prime of x in this purple color. So if we look at f of x right over here, it looks like its slope is pretty much consistently -2 over this interval between x equals, I guess it's like -8.5, all the way up to x equals -2. It looks like the slope is a constant -2. So if I were to draw its derivative would look something like this. Its derivative looks something like this. But then something interesting happens at x equals -2. Right as we cross x equals -2, it looks like the slope goes from being -2, it looks like the slope goes from being negative to being positive. And it looks like right out the get-go, if I were to estimate the slope of its tangent line, it starts changing. It's not a line anymore, it's a curve. The slope of the tangent line right at this point looks like it's around, I don't know, looks like it's around 3.5. Because if I were to draw a tangent line right over here, it looks like if I move 1 in the x direction, I move up about 3.5 in the y direction. So I'm just trying to obviously estimate it. So it looks like the slope goes up to 3.5 right when I cross that point. And then the slope becomes lower and lower and lower all the way until I get to this point right over here, all the way until I get to x equals 2. And then it looks like it continues to get lower all the way until you get to x equals 3. So it looks like the slope of the line is, and it looks like it's getting lower at a constant rate, I guess I could say. So it looks like it's doing something like this, something like this over this interval, But then right as x crosses 3, this becomes a flat line. The slope is 0 here. So right as x crosses 3, the slope becomes 0. So we immediately see there are points where it looks like the slope jumps. And at these points, we really don't have a defined derivative. The slope jumps there as well. And so at what arguments is f not differentiable? Well, it's not differentiable when x is equal to -2. When x is equal to -2, we really don't have a slope there. If we tried to find, remember, when we're trying to find the slope of the tangent line, we take the limit of the slope of the secant line between that point and some other point on the curve. If we did that as we approach from the left, it looks like the derivative is -2. If we do that from the right, it looks like the derivative is something like +3.5. And so we're not getting the same limit of the secant line as we approach from the left and as we approach from the right. And the same thing is happening at x is equal to 3. At x equals 3, as we approach from the left, the slope looks like it is decreasing and it is approaching, I don't know, maybe around -1. But then as we approach from the right, it looks like the slope is 0. So we do not have the same limit of the secant slope as we approach from the left and right-hand sides. So at both of these points, we see the derivative jump, and it looks like f of x is not differentiable.